Now, if you remember back to the last video that you watched, we talked about nitrogen and we did the electron configuration for nitrogen. So nitrogen has 7 electrons, but when we did the abbreviated configuration, we saw that the abbreviated configuration is helium, 2s2, 2p3. Okay, and what that tells us is that electrons in the outermost shell, or the 2 sublevel, are the 2s electrons, there's 2 of those, and the 2p electron, and there's 3 of those. Okay, and those electrons, the ones in the outermost shell, are the valence electrons. And we represent these valence electrons with a symbol called the electron-dot symbol. And an electron-dot symbol is a convenient way for us to represent the valence electrons as shown by dots on the side. So for example, if we look at nitrogen again, 2 plus 3 is 5, so nitrogen has 5 valence electrons, and the electron-dot symbol for nitrogen would look like this. And it doesn't really matter which sides the dots go on, just that there's the right number total, and you put 1 on each of the 4 sides, and then you start doubling up if you get more than 4 electrons. And the ones that are on the side alone, like these here, those are called unpaired electrons because they're not paired up with another electron. And then the ones that have 2 on the side, like this one, those are called non-bonding pairs because they're paired up but they're not involved in a bond. And we're going to talk in the next section or two about what it means for a pair to be involved in a bond. And one neat thing about the way our periodic table is organized is that each group has every member of that group has a set number of valence electrons, and we can determine that by the group number. So for example, hydrogen, lithium, sodium, all of the alkali metals all have 1 valence electron. The alkaline earth metals all have 2. If you go over to the noble gases, they all have 8 except for helium, which is an exception. And then the halogens all have 7 and so on. So this is our periodic table, but you could just imagine the transition elements being stuck in this region here. And these are the group numbers that are at the top of each of the groups on your periodic table. So you can just look at your periodic table and know how many electrons how many valence electrons a particular atom is going to have. So you could go to carbon, for example, and if it's in group 4A, and so you know that means that it has 4 valence electrons. In order to get an ionic compound, you first need ions, and there are 2 kinds of ions. There are ones that have a positive charge and ones that have a negative charge. The ones that have positive charges are called cations, and they are named just based on the name of the element they come from. All of our cations that are single atoms are metals. And so metals, because they're over on the left side of the periodic table, they don't have very many valence electrons, and so they tend to lose their valence electrons in order to have a complete shell. So sodium has 1 valence electron. If it wanted to complete its shell by gaining electrons, it would have to get 7 more electrons, which is just not going to happen. So in order to be fulfilled by the octet rule, it loses 1 electron. And if the number of protons in the nucleus stays the same, but it loses 1 electron, it loses 1 negative charge, and so that gives the ion that's left a positive charge. And we call this a sodium cation. Simple enough. So if we look at another example, what would you expect to form from an atom of magnesium? So if we look at our periodic table, magnesium is in the second column, or the second group, and it has 2 valence electrons. So in order to have a full energy level, it would either have to gain 6, which is not likely to happen, or it's going to lose the 2 that it does have. So magnesium loses its 2 electrons and forms Mg2+, or the magnesium cation. Negatively charged ions are called anions. And so we have an example here. So if nitrogen has 5 valence electrons and it gains 3 more in order to get to 8, then we call it nitride. So while cations just maintain the name of the metal that they came from, anions take on a new ending when they become an ion. So nitrogen becomes nitride. If you were to make an anion from oxygen, it would be oxide. If you were to make one from chlorine, it would be chloride. So anions always end in IDE. Okay, so what would we expect to form from an atom of fluorine? So if we look at our periodic table, fluorine is in column 7, and it has 7 valence electrons. Okay, so again, it's not likely to lose all 7 of those electrons. So the more likely thing to happen is that it's going to gain one more, which is going to bring it from 7 to 8, and so it's going to have a full octet, and that gain of one additional electron will give it a -1 charge. So we'll have F minus, and it will be called fluoride. Since we just talked about how we can predict ionic charges from the periodic table, or from the valence electrons, it shouldn't surprise you then that we can use the periodic table to figure out what charge an atom is likely to take on. And so we just did an example from the alkali metals. Sodium is an alkali metal, and all of those have one valence electron. So the elements in that column are always going to form +1 cations. In group 2, they always form +2 cations. We're going to skip over the transition metals. You'll see over and over again that they behave very differently than everything else. So we're just going to look at the main group elements for today. In group 3, the only metal in that group that we really do a whole lot with is aluminum, but it forms a +3 because it has 3 valence electrons. Group 4, you'll find because it has 4 electrons, it doesn't really want to lose 4, and it doesn't really gain 4 either. And so what you'll find is things in that column don't tend to form ionic compounds, or the ones down further do, but we'll talk about those later. So we're going to skip that column. The ones in group 5, nitrogen is in group 5, and we said it's going to gain 3 electrons to get to 8, and so that group has a -3 charge. Group 6 has to gain 2 electrons in order to get to 8, so those have a -2 charge. And in group 7, they need to gain 1 electron, and so they all have a -1 charge. And then this last column here, all of the noble gases already have 8 electrons, and so they don't form ionic compounds either. All right, so you can see that the metals, which are on the left side of the periodic table, tend to form cations, and the nonmetals, which are on the right side, tend to form anions. And we're always working toward getting a full outer shell when we make an ion. All right, so we're going to stop here, and then we'll talk next time about how these ions come together to form compounds.